We didn't do this. We barely finished question 8. We were about to be starting 6, right?
Yep.
I'm going to do one more part of 5 before going to 6.
5, 6, 7.
Just to remind you how we do synthetic division. And there is an announcement. In calendar, it looks like we're doing section 3.4, but Columbus in the last minute canceled section 3.4. So we will skip 3.4, okay? We'll go directly to 3.5. So one less section in this course. Great, right? So we have actually one more class hour available, since we have one less. I think we are on schedule right now, so you can ask more questions if you wish. All right, number 5. Why don't we do part 2 together? Because it looks like a weird one, right? 1 over 3, f of 1 over 3. We did part A. Why don't we go over part B? How do we compute f of 1 over 3? Not by direct substitution. I know you can substitute here cube and 3 times and squared, etc. But how do we use this theorem above, remainder theorem, to compute f of 1 over 3? Remainder theorem says if you want to compute f at a value, all you need to do is divide the polynomial given by x minus this number and check out the remainder. That remainder will be f of 1 over 3. So all we need to do is do synthetic division of this polynomial, which is 3 minus 1, 15, and 5. And we are going to put this number with opposite sign here. Am I right? No. No. So this f of 1 over 3 means divide polynomial by x minus 1 over 3 and check out remainder. So you already have a negative in front here. Its opposite is positive 1 over 3. Okay? So you take this number as it is without a sign change and do the synthetic division. Is the right side correct though? Do we have any skipped powers? Because if there are some skipped ones, we put zeros. No, we have everything fine in the descending order. Great. So we can start.
Should 15 be negative?
Yes, that part is missing. Thank you. 15 is negative. Next, we put the horizontal line here. Bring this down. And keep multiplying and putting the result to the next empty spot, one above this number, okay? So multiply 1 over 3 times 3. Oh, that's great. What is 3 times 1 over 3? It's 1. So this is positive 1. Negative 1 plus positive 1 is 0. Wait a minute. Do we subtract or add? In synthetic, we add. 1 over 3 times 0 is 0. How convenient is these numbers? So negative 15 plus 0 is negative 15. And 1 over 3 times negative 15 is, this is a tough one. Wow, you guys are great. 1 over 3 times negative 15 is, it's just basic cancellation. 3 goes into 15 5 times. It's actually negative 5. Oh my god. 5 and negative 5 is 0. It's a perfect division. That means remainder, this is remainder, 0, That implies f of 1 over 3 is 0. Without any substitution, we figure that out. Okay? Otherwise, you have to cube 1 over 3 multiplied by 3. A lot of work, you will get the same result. This wasn't too bad. Took us only a minute or two, right? So we just remembered synthetic division now, right? Okay, you can do the rest. Same way you multiply, put to the next number. Okay. Now, what is in 6? What is new? We have a brand new theorem. It says if you enter a number into the function and it makes it 0. By the way, once you put a number into f and it makes it 0, what is that number called? It has a special title. A 0. So if you know c is a 0 of the function, 0 maker of the function, then you subtract that c from x. That part you make, x minus c, whatever that number is a factor of f of x. What's the meaning of a factor? That means you can, for example, in this question I'm talking about, if x plus 1 is a factor of this polynomial, that means you can separate it from the group and put that thing in parentheses. If it's a factor, I don't know if it's a factor yet. You know, and also, if x minus 4 is a factor, you can separate it from the group with a parentheses and turn it into multiplication with other stuff. That's what factor theorem says. But what is the catch again? You need to prove that 3, I'm sorry, it's not 3. It's minus 4. 4 and negative 1 are zeros of the functions that they are factor. And the opposite is correct as well. If you know x minus c is a factor, like x minus 4 can be pulled from this polynomial, then 4 or minus 1 are zeros of the function. When you enter them into function, they make 0. So it's a both-sided relation. 0 is a factor, or if you know a factor, and that number is a 0. Is a 0 maker. Got it? All right, let's test it. We don't know this yet. I just hypothetically put it down. So they say use the zero factor theorem to determine if this given part, x plus 1, is a factor of the polynomial. So there are a couple ways to do this. Part A, you want to check x plus 1 factor or not. If you want to find out if this is a factor by zero theorem, by factor theorem, all you need to do is enter opposite of this number. What is opposite of plus 1? Negative 1. Enter f into negative 1. See if it makes it 0 or not. If it makes it as a 0, the answer is yes. Otherwise, if it's not 0, the answer is no. It's not. It can't divide it. It cannot divide it, so it's not a factor. So let's test it. What is f? X to the 4th. So we don't know this yet. So I'm going to clean these. We don't know these as 0 yet. I will just compute f of minus 1. Substitute minus 1 everywhere. Every x will turn into minus 1. What is the answer? What happens if you multiply negative 1 4 times itself? Negative 1 times negative 1 times negative 1 times negative 1 is 1. Even powers of negative numbers is positive, and 1 raised to any power is 1 anyways. And odd powers of negative 1 is negative 1, but 7 times of it is negative 7. Agree? Plus 7 times square of 1 is 1. 7 times 1 is 7. 5 times negative 1 is negative 5 and plus 4. Alright, what is the answer? These are canceling opposite numbers. Negative 5 plus 4 plus 1. Perfect. So what's the verdict? What's the answer? Is x plus 1 is a factor? Yes, it is. This is option 1. What is the other option? Look, maybe you guys don't feel confident with raising powers of negative 1 for fourth power. Maybe you don't know how to do this. You don't have a calculator. How else would you compute f of minus 1? How else could you check if x plus 1 is a factor? I'm asking you this. How can you test if 3 is a factor of this number, 243? How can you be sure? What's the meaning of a factor? What? Anyone? If divisible by 3, we call it a factor, right? You go ahead and take 243 and divide by 3, do this work, and see if you get 0 remainder. Yeah, we say 243 is divisible by 3, or in other words, we call it 3 is a factor of 243, and this number here, like 81, right? Is it 81? 81, the result is the other piece missing. So that's how you prove things are factor. So if you don't like doing this, the other way of doing this is see really x plus 1 can divide this or not, okay? Alright? But we are not really using factor theorem then. Okay? But if you want to do that, I just want to present that option. If you want to test x plus 1 is a factor, you need to check if minus 1 synthetic division with this, what is it? 17754, right? 17754. This shouldn't take more than 30 seconds. There you go. It's a factor, yes. Okay. Just take this down, multiply negative 1, add 6, multiply again negative 6, add 1. We get 1 times minus 1, 4, negative 4, 0. This is the second part. Yes, x plus 1 divides that. Divides. Divides means factor. It's a factor. Alright? So you either substitute or literally divide. That proves it's a factor. What do you think about the second part? This one. Is x minus 4 a factor?
No.
Alright, which one you want to do? Let's do the factor theorem again. Substitute negative 4 into the polynomial. I will enter negative 4 everywhere. Good. I'm glad you caught that earlier. We are supposed to enter opposite of this number. It says so. If it's x minus 4, you enter positive plus c. No, we leave out the negative. So it's positive everywhere. 7, 4 squared, 5, 4. I'm not checking this. It's ridiculous. This is not making 0 for sure. Look at this. 4 raised to the 4th power is what? 256 times another big number. Big number, big number. It's getting bigger and bigger. It's not going to make 0. Right? Right? Obviously. So not factor. Alright, all you need to do is check the given binomial is a factor or not. Direct substitution, or double method. Second method is division. In any case, A is okay, B is not. Alright? Let's go to the next one. Oh, what do you think about this one? You're given a polynomial, degree 3. In the first part, I want you to factor f of x. Factor means really you need to get all those parentheses resolved. But they help us with the information. They said -1 is already a 0. What's the meaning of this fact? This fact says being a 0 means if I enter -1 into that function, what do you expect to get? When you enter -1 into function, what is the result? What? 0. Yeah. The meaning of 0 is when you enter that given value, -1, f will be 0. If you don't trust me, just plug it in. -1 cubed times 3, -1 squared times 20, -1 times -11. And -28 is going to make 0. Okay? Alright. I wonder how I can use this to factor. Again, factor means, question is factoring this. They want us to split as 3x cubed 20x squared minus 11x minus 28 into several parentheses of binomials, preferably. We expect to get as many as 3. How do I know we can get as many as 3? It can be less though, but it cannot be 4 different parentheses. How do I know how many parentheses I'm going to get? Because of this. You can get as much as this number, 3 parentheses, but it can be less, but not more than 3 for sure, not 4. Because if you have 4 stuff with x's, when I FOIL these, multiply, I will get x to the 4th. This is cube, impossible. Okay? So I know at most 3, maybe less, because sometimes one of the factors is like this, and this is not separable. You may get only 2. X times x squared is x cubed. Not third one is redundant. It doesn't happen. But I will take the worst case and say it can be 3. Alright, but you already know one of them. How and what? You already know one of these pieces. Which one? How did you know that? Because if I know a c makes my function 0 from the previous fact, if I know a number making my function 0, then x, the opposite of this number, is a factor. So what is the opposite of this number? +1. Okay? So I already have this in my packet. Check. You have 2 more fish to catch. Those 2. But I don't know they are separable yet. I will first find the big fish, and then I will chop it up into 2 more pieces. Let's first catch the big one, and we chop it up, if possible, into 2 more pieces. Let's find this. How do I get this big part? Let me ask you this. If I give you 64, and if I give you 4 is a factor of this function, this number, how do you get the other part? You divide, right? You take 64 in here, 4 to the left, and you start dividing. 4 goes to 6 once, right? You do this. Isn't it the same thing? This is your 64. Somebody already give us 4, and they are asking what's the other mysterious number missing. And all you need to do is take this big fat polynomial and divide by x plus 1 and find it. And which division do you prefer? Which method? You learned 2 last time. Which one? Synthetic. Why not long? Because long division is long, right? So it's a long one. We don't want that. Do synthetic, but is this suitable for synthetic? Yes, because it's just x and a number. So I'm going to set up my equation. This is 1. Am I taking it 1 here? No, we take opposite, -1. And then, what? You want? Is the setup correct? Let's divide. This guy going down. 1 times -1 is -1. 20 add -1 is 19. 19. 8 minus 8 minus 36. I know I have a mistake. How do I know I have a mistake? Somewhere here I messed it up because this guy must divide it. I know by heart. 4 divides 64. I know it's given that this thing divides this. I should have gotten 0 here. I didn't. There was a mistake. Where?
They brought 3 down.
3?
Should have been -3 instead of -1.
This one?
3 got brought down as
Oh,
one
I
instead
got
of
it
three.
at all mistake all everywhere. Okay, in the beginning then. Okay. So don't rush. Everything is wrong. Actually, I intended to make a mistake here. I actually had a real mistake there. I didn't do it really intentionally. So that was a real mistake. So this was 3. And yeah, I need to clean this. -1 times 3 is -3. Add 17. -1 times 17 is -17. Add it's -28. -1 times -28, 8 is positive 28. And no longer mistake. I'm sure I did everything right. Because I got 0 remainder. This is remainder. Means it's perfectly divisible. The polynomial is divisible by x plus 1. But I do care about the result, quotient. What is the other fat fish here? And where do I get it? I already knew it's divisible. I'm not interested in this part. Where do I get the missing part? I'm looking for it. It's right here. How do I write it? Oh, 3, what? Is it 3x squared or minus 28x x squared or x cubed? Which way? Yeah, we start with the constant. This is wrong. We always start with the constant and then raise x's. So this is constant. Add x all the time. 3x squared, 17x minus 28. Okay. I caught the big fish here. But it's still too big. We need to chop it off. You need to break this into 2 pieces. I cannot clean this part. This was an intermediate step. I got what I want, so I don't need this work anymore. And on the exam, don't clean it because you may need to go check your work sometimes. So keep it on a safe spot. So I want you to break this into 2 pieces. There are 2 options you can go with. First one is trial error. Try to guess what 2 terms multiply into 3x. It's easy. One of them should be 3x, the other one should be 1x. So it can make 3x squared. There is no other option. You can't take 2 and 2, it makes 4. You can't take 1 and 1, it makes 1. One side should be 3, the other one should be 1. That part is easy. Question is, how do you break 28 into 2 parts, 2 numbers? The product will be negative 28, but when you FOIL outside and inside terms, the total will make positive 17x. Positive 17x will be the total. What 2 numbers would you go with? What's that? Yes?
7 and negative
7 and negative 4. Let's test. Positive 7, negative 4. Let's multiply outside terms. Oh, outside is 3x minus 4 is minus 12x. Inside terms is 7x. When I add like terms 7x minus 12x, unfortunately I'm not getting 17. We need a revision.
4. The other way around, negative 4.
Okay, good. Why don't we flip their locations? Put 7 on the right, 4 on the left. 7 here, negative 4 on there. Now this is negative 4 and 21. Negative 4x, 3 times 7, 21x. And the total is 21 take away 4 is 17. In 1075 we learned something called AC method. If you wish you can do AC method. You multiply the first and last terms and try to guess. That works as well, but this is faster if you're good with number multiplications. So we got the right pair. So I think we're done. Factor it. And we did. The total factoring is x plus 1, 3x minus 4, x plus 7. Any questions? That will be part 1, I think. There was a second part. No, we're gonna have to type this entire thing here. Was it this? It wasn't. 3x minus 4, x plus 7. There you go. Now they're asking for numbers that makes this polynomial 0. Look, says solve, set the entire f of x into 0. This is your f of x. I will set it into 0, and they say solve it. That's part 2. Okay. Now, guys, please, can you set this into 0? Yes, and solve it. Part B. 3x cubed minus, was it 20? Positive 20. Can you guys tell me how do you solve this? It's a cube extension. Cube square x 28. I have no clue how to solve this.
So each factor is 0 instead.
Okay, where are the factors? Yeah, right above. So we factored this. Why don't we use this form instead of this? how easy this is. There are three terms, multiplying into 0. Rules of math says either one must be 0, otherwise they will never make 0. So you need to take each and every factor you see and set it into 0. So we get minus 1. What do we get here? 4/3. Add 4, divide by 3. And they expect this solution set. Alright. One question. These are called solution set. This is called solution set. But what do you actually call each and every one of these numbers? They are called zeros of the pound. You actually found in this activity, what happened? You found zeros of, you found, well, something weird happening. Did we erase something or? I'm confused.
You brought
Yeah.
it back to problem 6 instead of 7.
Oh, I was writing in 7? Oh.
No, we were on 7.
Wait, what happened to 7? I believe in ghosts now. I think it's been recorded. I kind of deleted it. There's a magic button. I deleted it, but those three numbers we found were called zeros. They are zero makers. Zero makers, they make zeros, so call them zeros. 4/3. You can put them in any order, okay? -7. Alright, now we are in the last question. This is kind of easy. This is a new fact. It's not mentioned earlier. If you know the zeros of a polynomial, you can construct that polynomial from its zeros. This is the fact. Any polynomial whose zeros are known will be on this form. X minus the first zero, x minus second zero, x minus third zero. You can do this all day. X minus fourth zero, fifth zero. As many as you could keep doing this, as many as the number of zeros. In this question, how many zeros we know for sure this polynomial has? 2. So you will have only 2 parentheses, x minus the 0, x minus the other 0. That's it. So you don't need 3 pieces. Again, if you are given 3 zeros, you will have the 3. If it's 4, 4. If it's 10, you will do this 10 times. All this gone. Now what is this first number called? It's called leading coefficients. This may vary. So they need to give you this leading coefficient automatically, or they need to give you an extra piece of information to solve for it. So what do we know about the leading coefficient? It's given 1 already. So all you need to do is make this thing 1. Easy. What is the first zero given? Which one do you want to use? Which one is the first? Which one is the second? Doesn't matter. You can take this one the first if you wish. I take that one. It's x minus 4 root 5. And the second zero is this guy. It's x minus 4 root 5. Again, we're always taking opposite of these values here. Look, this turned into minus. This turns into what? When you multiply two minuses? Turns into plus. So it's x plus 4 root 5 and x minus 4 root 5. Well, they don't want it in factored form. You need to actually expand this, FOIL this, and turn this into standard form with x is raised to powers. So do you guys know how to extend this? First terms outside, inside, last terms. There is an easy way to extend this. This is one of the common factored forms. A plus b, a minus b. What happens if you multiply a plus b, a minus b? Anthony? A squared minus b squared. So it's square of the first, square of the second with a minus. Square each, you're done. Because this is called square difference formula. A plus b, a minus b. A is x, b is 4 root 5. Or literally, expand this out, FOIL it. The middle terms will drop out. They will be opposite, equal and opposite. So they will cancel out to this thing. Just here. Can we square this? What is square of 4 root 5? Anyone? Just square and square root cancels each other. We get 4 times 5, 20. Is that right? 20? These are cancelled. 5 times 4, 20? No, we need to square this one as well. So it's 16 times 5. So 16. And this is just 5. So it's 80. X squared minus 80. Okay? So that polynomial we were looking for was x squared minus 80. Alright, any questions? Zeros are over. I'm glad 3.4 is cancelled. So this is the only zero finding questions you learned. What we'll be doing in 3.4, if you want to read it for your own information, is we will be doing more finding zeros methods. There are some tests you can apply, but they're not directly related to your major, so please skip that section. Alright, we have still 10 more minutes. We can go to next homework. We are going to investigate rational functions in this section. Take a look at the first 5 letters in the title. What do you see in rational? Ratio. What a coincidence. We have a ratio, nothing but a ratio. So ratio of a polynomial with another one is called rational function. That's it. Rational function is a ratio of polynomial with another. What is a polynomial? X's with powers added or subtracted. That's it. You will see some x's with powers on the top. You will see some other x's with powers on the bottom. Their ratio is called polynomials. Rational functions. So let's take a look at which ones are. No, these are all rational functions. What properties all these rational functions have? I actually want to give you some non-rational ones. For example, what do you think about this one? Root x squared over x cubed. Is this a rational function?
No.
The bottom is a polynomial. The top is almost a polynomial except this. Square root x is equal to x to the 1/2. It's a split power. It's not a whole power. if you don't have a whole power, we could not call this a polynomial. Top is not a polynomial, so this is not a rational function. It's a ratio, but another rational function. So we will not see this kind of things in this section. Only whole powers. Look, whole power, and numbers in front. Whole power. Wait a minute, there is no power here? It's okay. If you don't have any x's, this is called constant function, or it's actually a monomial with no x, 0 degree x. You actually have an x to the 0 here. X to the 0 is 1. 1 times x to the 0. Even this one is called rational function. Alright, once you're given a rational function, to be really pick all the benefits of this function, you need to factor it. Without factoring, you can't get much information out of it. Just like quadratic functions, we turn it into seed form, vertex form, and get vertex, max, and mean, intercepts. Rational functions are best if you factor them. So once we are given a rational function, we will try to factor, especially the bottom side, denominator. Okay? And this one can be factored, x squared plus 5x minus 2 as this. By trial error method or AC method, you can factor it. But this one won't factor. How come? I expect to factor this as x plus 2, but it's actually not factored. This is not true. Because when you FOIL x plus 2 and x plus 2, you get x squared, 4, and then 2x and 2x. You get 3 terms. You get 4x in the middle, which is not correct, of course. Oh, can we take one of them negative? No. When you take one of them negative, this turns into negative. X squared minus 4, square difference formula. In short, no matter what you try, you can't factor that thing. This is not factorable. Again, why do we want to factor it? To be able to check out what numbers in x, you substitute in x, makes this denominator 0. Well, why do you care it becomes 0 or not? Why do we care it becomes 0 or not? Why is it so important?
Because the denominator can't be 0.
Right. If the denominator of a rational function becomes into 0 like this, when you enter 0, this thing is undefined. So your rational function is blown up. It's dead. It's broken. So rational functions are extremely sensitive for some numbers. Those numbers making denominator 0 must be taken away from their domains. Such as 3/2 is bad here. How did they get 3/2, by the way? You set each piece into 0. You find zeros of this bottom polynomial. 3/2 is the 0 of the left. Minus 4 is the 0 of the right. We exclude them from our domains. In interval notation, it splits into 3 pieces. Again, this is in the background what they did. This is your entire domain, but we just found 2 bad guys. Once they ride into this bus is dead. Okay, bus is broken. Those bad guys are 3/2 and minus 4, so we need to exclude them. 3/2 and minus 4 is next to it. Is it here? Minus 4 to the more left, right? Is on the left side of 3/2. This is 1.5. Minus 4 is more negative here. So we need to have 3 pieces. Left piece, middle piece, and right piece. This is the right one, this is the middle one, and this is the left one. That's how they got these 3 pieces. They observed that there are 2 holes in its domain. You exclude them, you have 3 pieces of line. This one is a beautiful, really rock solid rational function. Why? Because nobody makes this function sick. It's rock solid, right? Try entering some values. Can you find any values you square and add 4 is going to make it 0? Let's try. Magic ball, please tell me what makes this function 0. Right, you don't need a magic wall for this, you just need to know algebra. Subtract 4. And do you have any numbers squared into minus 4? No, when I take square root of both sides, this is undefined. I can't get square root of negative 4. That means you will never be able to get a number making this 0. That means its domain is everything from left to right. Everything. So that's what it means, or this special R. Okay? Some rational functions, perfect. Some of them are fragile, bad, blow up in some numbers. Some of this one has one bad number, which is 0. So you shouldn't be making 0. There is a hole right in the middle, so there are 2 pieces. Okay? Trust me, this is what we will be dealing with in the entire section. All those bad guys create something significant, like vertical asymptotes, we will call them. So spotting these bad guys is crucial. There will be something special coming up. Okay? Before that, let's see really what's happening around those bad guys. So who was the bad guy for 1 over x? 0. So somebody took close numbers to 0, like minus 1. Minus 1 is not really close to 0, but they took something. No, it's, where is it? Yeah, they did it here and there. These two. Please take a look at these two. Please. This. Yes, they took minus 1 and they got minus 1. Okay, minus 1 wasn't close enough to 0, so they got closer to 0. They took minus 0.01. It's close to 0, right? And the function value, when I enter minus 0.1 here, 1 over minus 0.1, take a calculator and do it, you get minus 10. Oh, they weren't content, they weren't happy with this, they just got closer. Look, 0.01 is really close to 0, that it became 100. And they did add one more 0, 0.01, and the result is even bigger. So you are getting big, bigger, really big. And imagine when you are really, really close, too close to 0, too close. I mean, 100 zeros and then 1. What do you expect this number to be? Just follow the pattern, please. If you have only 2 zeros, you have triple zeros. If you get 3 zeros, 4 zeros, right? If you have 1 million zeros after the dot, what do you expect to get here? A huge, really negative, huge number. How in math, how do we represent negative, huge numbers? What is the hugest negative number you can think of? It's actually inverted 8 infinity, right? So negative infinity, I see that on the left side of 0. By the way, these are negative but close enough 0 numbers. So these are the numbers you picked. You're getting closer and closer and closer. Your numbers are getting lower and lower in negative sign. So they will be negative, huge numbers eventually. So we see that when you're getting closer to bad guy, your bus is going crazy, going down like a subway. It's drilling to the underground, okay? And going to China, okay? But when on the right side, when you are picking right side of the 0, this is the danger zone. Let me mark it. This is electric fence. Bad guy is right on here. Here is the bad guy. You're getting closer to bad, and your function says, no, I don't want to get close to this electric fence. Just take me anywhere else, and he goes to infinity. So your function is avoiding that bad guy. But to avoid that bad guy, you either go up or down. And when that happens, you're actually creating a vertical asymptote. This electric fence is called a vertical asymptote. Okay? We'll talk more about them tomorrow. Anyway, we still have 5 minutes. Where are you going? Okay, now you can go. You're giving me a false alert.